Hi, everyone, and welcome to our ISARC presentation about a proposed curriculum for teaching the Tri-Constraint Method of Generative Construction Scheduling. I'm Daniel Hall. I'm an assistant professor at ETH Zurich, and I've worked on this with two very talented master's students and course assistants. And what we've tried to do is develop a new curriculum, which we'll get into and share with you. We're also excited to say that this paper has continued past the conference, and we actually just found out today that it's been accepted as a journal paper in Advanced Engineering Informatics. So you can look for that in the very near future. But let's get into it. So the first question is, or the first point of departure is that as a professor, and many of us are instructors here, teaching construction scheduling is one of the most critical components of a construction management program. And we need to make sure that students are able to put together a schedule. Now, compare that with trends right now of artificial intelligence and the rise of a lot of Contech companies that are bringing with them new AI methods for construction scheduling. And we're faced with two choices. The first is that we can kind of say this is advanced, that we don't want to teach it to our students. We'll focus on critical path method. Or we can look at approaches to bring automated construction scheduling to our construction management curriculum in a way that's understandable and avoid students from dealing with black box software situations. Now, furthermore, I think there's a lot of limitations of the critical path method that we need to address. And in particular, Dalasega points out 4 that are key to our work. The first is the critical path method suffers from a lack of automation. It lacks dynamic change processes. It makes assumptions about unlimited resources, and it has very little consideration of spatial or location constraints. This last one is really important because I feel that the critical path method is not necessarily compatible with the potential of building information modeling. What do I mean by that? So if you look at the critical path method, typically what we do in connection with BIM is that we create a project schedule, and then we connect it to the BIM. But the BIM is not informing, or we're not deriving the schedule from the BIM in the first place. So the question I have, is this really the future of construction scheduling, or are we going to see something different? From our point of view, something different is occurring. We're starting to see generative scheduling algorithms, such as this one shown here, called the Tri-Constraint Method. And these generative scheduling algorithms are being used for the creation of new approaches to construction scheduling. And just to quickly go through the Tri-Constraint Method, which was developed by Morkos and adapted from Way's smart scheduling algorithm, we create a set of to-do tasks. Those include have a precedence constraint, which allows us to filter to a can-do list. And we then apply a disjunctive spatial constraint and discrete resource constraints, in the end looping through until no more operation is available in step 8. We don't have time to go into all the details of the critical path method. I would refer you to the dissertation of Renee Morkos to see how this works in greater detail. So based off of this, we have 4 key research questions that we want to understand with these new generative scheduling algorithms, and in our case, in particular with the Tri-Constraint Method. First is, what is a successful curriculum design for teaching this novel scheduling algorithmic approach? And can we design a curriculum that would achieve balanced learning objectives between theoretical knowledge, how does the algorithm work, computational understanding, how does this then algorithm translate into computational language, and practical implementation, how do we deploy it for real on construction projects? And so to do that, we created a methodology that, we used a methodology that included the creation of a new curriculum to teach the Tri-Constraint Method. We implemented it in autumn 2020 over 5 weeks, and then we evaluated its effectiveness on student learning. And for the course design, I now hand it over to Ravina.
So the lectures of this curriculum are based on the flipped classroom approach. So the new content is introduced and deepened over 3 sessions. In the pre-class homework session, the students acquire the knowledge independently, and then in the in-class activities, they deepen their knowledge by repeating the pre-class content, by doing activity-based learning, and by discussing the results of these in-class activities. Then in the post-class homework, they further consolidate their knowledge by working on more complex problems and critically reflecting on them. This resulted then in a 5-week curriculum where in the first 2 lectures, the theoretical knowledge is taught, and the last 3 lectures, the practical application of it. So in the first lecture, the traditional scheduling method is taught. In the second, the Tri-Constraint Method, and then the last 3 weeks, the students learn to create schedules with Alice, where in the first one, they create a non-resource constraint schedule. In the 4th lecture, they create a resource constraint schedule, and the last one, they learn to optimize the resource constraint schedule. Now I would like to show you lecture 4 in more detail so that you can get an understanding of how the lecture was conducted. So 1 week before the actual lecture, the students got a pre-class homework where they watched 2 videos, and then they had to answer questions about these videos to ensure that they understood the content of the video. Then during the lectures, they worked on a simple Leo 1 model where they got introduced to the features of Alice by interactive demonstrations, and they also got time where they could work on their own, and this teaching team assisted them if they had any questions. Then for the post-class homework, they worked on a more complex Leo 2 model on their own, where they had to extract the relevant informations from the task sheets and the source document that we prepared for them. Now I would also like to give you some impressions of the lectures. Here you see an example of a Jamboard from lecture 1 where we got feedbacks from the students, and then we also discussed their inputs in the lectures. Here is another example, a short video here's also a short video of lecture 3 where Professor Hall introduces the students to Alice. And now Irfan will show you the results.
Thanks, Ravina. I will now talk about the evaluation of the proposed curriculum. During the first implementation in autumn semester 2020, we conducted an in-depth analysis of the performance of the curriculum. This included first the student assessment of the course, which revealed that the students are very satisfied with the course. This can also be seen in 2 exemplary quotes by students, where one student pointed out that the organization surrounding TCM was pretty good. And another student pointed out that in contrast to other courses which are too theoretical, this course, the student really liked this course because it shows a software Alice, which is really used on construction sites. We also did a detailed statistical analysis of the students' learning. So this was first done on the subjective self-assessment perspective and also through knowledge tests. The self-assessment was performed with prompts related to CPM, TCM, and Alice. An example is that students had to answer the question, I'm able to apply the algorithm of the Tri-Constraint Method on a given project. And in this figure on the left, you see that the percentage of students that mostly or entirely agreed with these prompts. What can be seen is that before the curriculum, some students had prior knowledge about CPM, but most of them assessed themselves that they have no knowledge about TCM or Alice. After the curriculum, most of the students, if not all, agreed that they assessed that they have knowledge on the topics of CPM, TCM, and Alice. The knowledge test revealed more details about the actual knowledge gain of the students. They were asked questions like, which of the following statements are true about the critical path method? And what can be seen from this table, which shows the results of pair t-tests for the knowledge tests, is that independent of the student's pre-knowledge, the pair difference between and after the curriculum are significantly high. This leads us to the conclusion that all students were able to achieve a knowledge gain. Furthermore, we analyzed the self-reported perception of how much the students think they know as compared to their actual knowledge. Before applying the curriculum, students had varying levels of prior knowledge about the planning methods. Their perception of how much they know about these planning methods varied also. After the curriculum, the students had better results with the higher knowledge, and their assessment of their knowledge was less spread. So they perceived the gain of knowledge due to the curriculum. So to sum up this presentation, we have shown the design, implementation, and validation of a new curriculum to teach the TCM within an existing construction management course. It was shown that there is statistically significant evidence that students were able to understand both theory and practical implications of the TCM. However, there were some limitations. First, there is a high pressure on the teaching team for initial implementation. Second, the constant collaboration with LS Technologies is required, but they expressed the willingness to collaborate with the other universities to implement this curriculum as well. And lastly, it's not sure how the future market share of TCM and LS will be, but we think that this curriculum approach can be adapted for other novel scheduling algorithms. So with this work, we think that we contribute to the body of knowledge with this advanced pedagogical approach to prepare students for working in highly automated and digital environments. And we think that we're lowering the barrier for CM courses to teach and foster the spread of generative scheduling methods. And lastly, we think that we help students develop soft skills for balancing different optimization strategies while working with a computational model. So thank you very much. As we think that this curriculum is helpful, we made it available open source, and you can find it using this link. We're looking forward to your feedback.